Breaking news. At 02:19 Coordinated Universal Time, less than 6 hours ago, something happened in deep space that should not have been possible. An object already classified as anomalous, already controversial, was caught in a moment of precision so exact that multiple independent instruments flagged it as an error. But it was not an error. Today, the impossible just happened. Moments ago, analysts reviewing fresh Hubble Space Telescope data confirmed that 3I Atlas entered a near-perfect geometric alignment, an alignment so exact, so controlled, that it immediately forced scientists to rerun every known physical model. This changes everything we thought we knew about interstellar objects. If you want real-time cosmic updates as they unfold, make sure you hit like, subscribe, and stay with us, because what we are witnessing tonight may not be a random event. It may be the beginning of something far more deliberate. Within minutes of the alert, emergency data packets were transmitted across 3 continents. Screens lit up simultaneously at NASA's Jet Propulsion Laboratory in California, ESA's Space Operations Center in Darmstadt, and the European Southern Observatory in Chile. The same numbers, the same angles, the same impossible jet orientation, and one question echoing through every control room: how did it do that? Before we go any further, it's important to establish why this moment matters and why the world's most trusted scientific institutions are taking it seriously. This observation did not come from a single telescope or a single team. The initial alignment anomaly was first detected by Hubble's Wide Field Camera 3, operating in the near-ultraviolet and visible spectrum. Within 90 seconds, the signal was corroborated by the James Webb Space Telescope using mid-infrared spectroscopy. On the ground, the Atacama Large Millimeter Array in northern Chile confirmed unusual directional emissions. Radio follow-ups were performed by the European Space Network's deep space antennas in Spain and Australia. This was global, this was coordinated, and this was real. At Harvard, orbital dynamicists paused an ongoing simulation to inject the new parameters. At Caltech, computational physicists rerouted processing clusters normally reserved for gravitational wave analysis. No one wanted to say it out loud, but the implication was already forming. An interstellar object, traveling at over 26 kilometers per second relative to the Sun, had just demonstrated a level of spatial precision that no known natural process could explain. To understand how we arrived at this moment, we need to rewind the clock. 48 hours before the alignment event, 3I Atlas appeared unremarkable by its own strange standards. It was still outbound from perihelion, approximately 1.9 astronomical units from the Sun, shedding material in a weak asymmetric jet. Spectral analysis suggested a surface temperature hovering around 310 Kelvin, slightly elevated but consistent with solar heating. Its trajectory was stable, its brightness curve was smooth. Nothing about it suggested what was about to happen. Then, 11 hours later, the first deviation appeared. A junior analyst at the European Space Network noticed a discrepancy in the non-gravitational acceleration data. The object's velocity vector showed a subtle change, only 0.03 meters per second squared, but the direction was wrong. Instead of pushing directly away from the Sun, the acceleration vector was angled, as if compensating for something. At first, it was dismissed as jet asymmetry, but when the correction persisted across multiple observation windows, concern began to grow. 6 hours before the event, Hubble detected a faint color shift along the object's leading edge. The reflected spectrum moved slightly toward the blue, indicating either a change in surface composition or an unexpected interaction with the local plasma environment. The shape of the coma tightened, the jet narrowed, and the noise level, normally chaotic for a comet-like body, became strangely uniform. At T-3 hours, radio observatories detected low-level electromagnetic fluctuations in the vicinity of 3I Atlas. Not a signal, not a transmission, but a repeating disturbance in the background field, occurring every 127 seconds. Prime, clean, exact. And then, at 02:19 UTC, it happened. Hubble's tracking system momentarily lost lock, not because the object disappeared, but because its orientation shifted faster than the prediction models allowed. When the system reacquired the target, analysts froze. The jet was no longer trailing randomly behind the object. It was aligned, perfectly. The emission vector pointed along a precise axis that intersected the ecliptic plane at an angle of exactly 17.000 degrees, an alignment no natural comet should even know exists. Within minutes, emergency meetings were convened.
Dr. Elaine Morozov, a specialist in non-gravitational forces, ran rapid simulations using every known jet-driven model. None could reproduce the observed precision. At ESA, Dr. Tomasz Klein compared the geometry to known spacecraft maneuvers. The resemblance was unsettling. At Caltech, a team attempted to attribute the behavior to anisotropic outgassing combined with rotational resonance. The math collapsed under its own assumptions. Still, the mainstream explanation was not abandoned. Hypothesis A formed quickly. An exotic natural process, perhaps a highly irregular internal structure, perhaps layered volatiles sublimating in a sequence that only appears controlled, perhaps magnetic dust interacting with the heliospheric field in an unprecedented way. After all, interstellar objects are rare. Our sample size is effectively 1. But then hypothesis B began circulating in closed channels. What if the jet was not a byproduct, but a mechanism? What if 3I Atlas was not merely losing mass, but using it? As the debate intensified, a second wave of data arrived, and it contradicted almost everything. Approximately 94 minutes after the alignment, the jet intensity dropped sharply, not gradually, instantly. The emission ceased as if switched off. At the same moment, the object's acceleration vector changed again, this time compensating perfectly for the loss of thrust. The net trajectory remained unchanged, controlled. This was no longer random, one internal memo read. It was responding. As if that weren't enough, JWST's infrared sensors detected a transient thermal spike along a narrow band beneath the surface, localized heating reaching 480 Kelvin, then vanishing. No fragmentation, no plume, just heat applied and removed. And then came the pulses. Exactly 37 minutes later, faint electromagnetic disturbances reappeared, same interval pattern, same amplitude, but now synchronized with the object's rotation period, a rotation period that had also just changed, shortening by 0.7%, as if angular momentum had been deliberately redistributed. In mission control rooms around the world, conversations went quiet. Encrypted channels lit up between agencies. Data access permissions were altered. Certain feeds went dark to the public. Official statements were delayed, not denied, delayed. On Earth, subtle effects began to ripple outward. A communications satellite over the South Atlantic experienced a brief orientation fault. Radio operators in northern Scandinavia reported unexplained interference in the VHF band. Magnetometers recorded a transient disturbance measuring just 12 nanotesla, well below storm thresholds, but perfectly timed with the latest pulse from 3I Atlas. Bird migration patterns shifted slightly in Eastern Europe, not dramatically, just enough to be noticed. In the middle of the chaos, the scientific argument reached a breaking point. Dr. Marcus Hale, a computational astrophysicist at Harvard, presented a model that stunned even the skeptics. Using conservative assumptions, he demonstrated that if 3I Atlas were capable of directional mass ejection with even 40% efficiency, it could perform course corrections indistinguishable from natural motion while still appearing comet-like. The room fell silent. Across the table, Dr. Sophia Renard from ESA countered with a naturalistic rebuttal, pointing to unknown interstellar chemistry and selection bias. Her argument was strong, rational, necessary. But it did not explain the alignment. It did not explain the timing. It did not explain the silence. As the hours passed, the object began to drift out of optimal observation geometry. The jet did not resume. The pulses faded. And just before Hubble lost its final clean tracking window, one last measurement came through. The alignment had shifted again by exactly 1 degree, on purpose. Now, in the calm after the storm, we're left with questions that refuse to settle. Are we witnessing a natural phenomenon so rare that it mimics intention? Or are we seeing the faintest outline of something else, something that moves through interstellar space not by chance, but by choice? Maybe we're not witnessing the end of certainty, but the beginning of perspective, a reminder that the universe is not obligated to behave according to our expectations, that intelligence, if it exists beyond Earth, may not announce itself with words or lights, but with precision. As I look back at the data feeds, I'm struck not by fear, but by awe. Whatever 3i Atlas is, it did not scream, it did not rush, it acted once, perfectly, and then went silent. And that may be the most unsettling detail of all. Because if this was a test, what happens when it wakes up again? Subscribe to follow the next update. This story isn't over.